When did that spark for mechanical engineer begin for you?
I got the opportunity to work with R&D. So it was steering systems in the first 2 years.
What does a R&D mechanical engineer do?
Functional prototypes cannot be used for live testing.
What is meant by simulation?
They go for this concept called digital twin.
Out of all the teams you mentioned, right? Which teams is a entry point for mechanical engineering graduates?
If a truck driver presses a brake, there would be 10-15 parts work in tandem to execute that brake.
And what tools or technologies you usually use in the skill set category? CAD modeling tools, automation or scripting, prototyping and validation, PLM and PDM tools. Hello everyone. Welcome to Beyond JD, the podcast where we uncover the real stories behind roles, growth and hiring. Today, we are taking a break from IT and diving into something different, a core engineering role. To all the mechanical engineers out there, this episode is for you. We are going to explore about mechanical design engineer, what the role is all about, the skills it demands, and what it takes to build a career in this space. And to share the practical insights about the role, we have a very special guest, Ranjit Kumar Kesavan, Deputy Manager R&D at ZF Group. He has around 10 plus years of experience in the field of research and development in mechanical design engineering. Welcome, Ranjit.
Hello, Soumya.
Yeah, we are very happy to host you here. Thanks for accepting my invite.
Thanks for inviting.
Tell us a bit about yourself and about your career journey so far.
I have over 10 plus years experience as you mentioned.
Okay.
So right after passing out of college in 2015, I joined in Rane Group. For the first 2 years I worked there. So after that I joined WAPCO. Then WAPCO was acquired by ZF. So I'm working as R&D mechanical design engineer role. So currently my role is deputy manager. Here I am primarily working in the space of commercial vehicle pneumatic brake systems. So where I take care of one of the product air compressors.
When did that spark for mechanical engineer begin for you? Like, I guess you did your engineering also in mechanical, right?
Yes.
So was it an informed career decision right after school, or it just happened like that?
If I have to frankly say, so right after completing our 12th standard, so we generally ask different people which career options are there, which one are the good options. So by discussing with so many people, I got to know that mechanical engineering has evergreen future,
Okay.
and I got so many good responses in terms of that. So and also the subjects interests me.
Okay.
So we do so many things physically. We see so many parts physically. So that interests me to join in this career.
Okay, I also found that you are working in the same company so far, right? So, can you share a few points? So, what inspired and motivated you through all this journey?
Okay.
Yeah.
So maybe it happened that in the campus placements I got
Okay.
the core mechanical domain.
Uh-huh.
So there I got the opportunity to work with R&D. So it was steering systems in the first 2 years. Then I moved to WAPCO. So there I got the opportunity to work in compressors.
Okay.
So our company primarily makes pneumatic brake systems. So the compressed air is a primary source of energy for the braking. So for the first 4 years, I worked for the conventional IC engine compressors. For the past 4 years, I am working for the electric compressors. As we know, as we see the shift from conventional buses to EV buses. Even we see in our roads currently that EV vehicles are running. So I'm working on that product. So
Okay.
it excites me that I could work on this space.
Nice. So, the type of work is challenging and exciting for you.
Yes.
I guess you studied in government school, right? So,
Yes.
starting from government school to being a key employee in a tier 1 OEM automotive industry company, I'm sure you might have faced a lot of challenges. Can you share a bit about these challenges and what steps you took to overcome these challenges?
So government school is one aspect and the medium of instruction is another aspect.
Okay.
So up to 12th standard I studied in Tamil medium.
Oh, nice.
So
Okay.
when we need to shift from Tamil medium to English medium in the college,
Uh-huh.
it was challenging initially. Then with support I got from the college, from the friends,
Mm-hmm.
by reading through multiple times. I got to accustomed to it.
Mm-hmm.
Then it helped me to further study in the English. I
Mm-hmm.
could not face further issues after that.
Okay, okay.
And then from the government school, so maybe I saw how difficult it is
Mm-hmm.
to study, and how difficult it is, how much opportunities we get
Okay,
generally.
okay.
So then when we moved to from the government school to another school, and then to College of Engineering
Mm-hmm.
Indy,
Mm-hmm.
it was a big transformation for me. By
Mm-hmm.
in a small village to a city to a metropolitan city, it was a big transformation. And then there the college helped me a lot to grow
Okay,
as an
okay.
individual.
Mm-hmm.
It showed various avenues for me to explore
Mm-hmm.
and improve myself.
Mm-hmm.
And then I could further and also it helped me in the campus placements.
Mm-hmm.
After that, it was all about liking the work
Mm-hmm.
and knowing new things
Mm-hmm.
that helped me to grow.
That's actually an inspiring journey. And for people like us who do not have any flashy background, for the first graduates, right? Education is truly a gold mine, right? Using the education in the right way not only transforms our lives but also transform a generation of
Yes.
lives, right? So you have used education very right,
Yes.
and actually we are proud of you. Yeah.
Thank you.
So let's now move on to the role based questions.
Yes.
What does a R&D mechanical engineer do? So what are your key roles and responsibilities? Can you explain it in simpler terms?
Okay.
Mm.
So when we see R&D mechanical design engineer,
Mm-hmm.
so the place we work defines what we do.
Okay.
So if we work in a OEM,
Mm-hmm.
OEMs are nothing but, if I say in automotive context, OEMs are nothing but the ones which make the end vehicles, like the two wheelers, the four wheelers, the buses, trucks, which we see in the road.
Mm-hmm.
And
What is the
then
abbreviation of OEM?
original equipment manufacturers.
Okay, okay.
And then
Mm.
there are products
Mm-hmm.
which OEMs does not design and make. They will take those products and design from the tier 1 companies.
Mm.
So the tier 1 companies does not make the end product.
Mm.
They will design, develop, and give the product to the OEMs based on their requirement. There we primarily need to understand what is the requirement of an OEM, and then we have to see whether do we have an existing part available in our portfolio, because development is always cost and time
Mm.
consuming aspect.
Mm-hmm.
And in our market, we have to be very agile.
Mm.
We need
Mm.
to be always bring the product at a faster time with reliable products.
Okay. You want to focus on cost optimization as well.
Yes,
Okay.
cost
Mm.
optimization as well as time
Okay.
optimization.
Okay.
So here, firstly, we will look for the products that fit in our existing portfolio. If we don't have that, then
Mm-hmm.
only the development life cycle starts.
Mm-hmm.
We have to understand the requirement, and then we have to make a 3D CAD model. From there, then we have to give it to the OEM for
Mm-hmm.
their acceptance. Once that is ready, we have to define the specifications and the drawing. That also we have to get it accepted by the OEM. So
Mm-hmm.
there are two types of tier 1 companies.
Mm-hmm.
One, the entire design is given by the OEM. The supplier just make build to print.
Okay.
The drawing here we talks as drawing. The
Mm-hmm.
drawing is given by an OEM.
Mm.
The tier 1 company just manufacture the part according to that specification and gives.
Got it. Mm.
And then there are other type of tier 1 companies where proprietary manufacturers,
Mm.
where the design responsibilities lies with tier 1 companies.
Mm.
So here I'm working in a proprietary manufacturing company.
Nice.
Here we need to understand the requirement. We need to split that requirements into multiple domains.
Mm-hmm.
And then under each domain we have to see, and we have to take from the existing portfolio.
Mm-hmm.
Then we have to look for, we need to go for the development,
Mm.
the 3D CAD modeling, the 2D drawing.
Mm.
And then depends on the criticality, we may go for the prototypes.
Mm. Mm.
And then we go, if we go for functional validation in the prototypes. Once that is also okay, then we will go for a series tool development. It's nothing but functional prototypes cannot be used for life testing. It cannot be used in the roads. It just check whether the product meets the function. Once that is okay, then we'll go for the series tooling, because the tooling cost would be very high. It would be in the range of 30-40 lakhs. So initially we will not go for that investment. We'll go for the functional prototype check, and then we'll go for the series tool development. Then we will do all our internal validation. Then that goes to the customer. They will also test in their vehicle. They will do the there are certain government norms that the OEMs need to meet
Okay.
with our part. So that also will be checked. And then depends on the requirement, they will go for the field testing also. You may see in the road, some vehicles carry a fully black or fully green color kind of a masked vehicle. So that's nothing but a field
Test
testing.
run. Okay.
Field testing is
Testing.
going on.
Okay.
So once that is also okay, then they'll go for the launch in the market.
Nice.
So if we take mechanical engineer's role, it starts from the requirement till the launch of the product.
Oh, okay.
That is in the development phase. After that also we have to further work on the cost reduction aspects. Based on the field feedbacks, we have to go for further improvements. And then up to end of life, our work goes.
So as I hear you right, I see your role as the mind behind everyday comforts. So maybe you're from automotive industry, so I'll take a car example itself. So when we lean behind the car seat, we feel that comfort. Or when we press that car's brake pedal, we feel that smoothness and control stops, right? So behind all these, there are design engineers like you who does months of research, be it stress analysis or ergonomics. So after all this product comes into market.
Yes.
Right. So in software, we do like iterative approach. We launch, iterate, build, launch, iterate, build. But that doesn't works out here, because the product, when it gets into the market, it should be perfect in the first place itself. We can't release a product and test with the customer directly, right?
We cannot play with
Yeah.
people's lives. So you mentioned about iterative approach in the IT. Here also we'll do the iteration, not with the physical products, but during the simulation phase.
Okay. What is meant by simulation?
So if we'll first design the product,
Okay.
then we'll see whether that fits with the actual testing through the simulation. So we'll currently this is being done for a long time.
Okay.
Recent times, all the players, whether it is OEMs or the tier 1 companies, they go for this concept called a digital twin.
Okay.
Digital twin is nothing but the physical testing, whatever we do after the prototype development or final product development, that has to be tested in the virtual space itself.
Okay.
So that the failures can be eliminated, and then the cost associated with the failure, be it the prototype development or the series tooling development, will be eliminated. So the iterations, most of the iterations will be done in the simulation phase itself. Then only it goes to the actual product.
Nice. So simulation is nothing but a virtual testing.
Yes.
As you grow in the corporate ladder, right? So from being a junior engineer to senior engineer, assistant manager, now you're a deputy manager. How does this roles and responsibilities change? Like how does it evolve? Like you, maybe a junior engineer works in a small component, or a manager works in a bigger part of component. It's likewise, or how does it evolve?
It depends on the place we work.
Okay.
Generally, in the general terms, if we take a vehicle has so many subsystems.
Okay.
If brake is a subsystem, steering is a subsystem, the HVAC, the AC is a subsystem, and then if we take all the outer bodies is a subsystem. Each subsystem has so many products.
Okay.
Maybe as I work in the commercial vehicle space, if a truck driver presses a brake, there would be 10-15 parts work in tandem to execute that brake.
Okay. Okay.
So only if that happens, we'll have the perfect braking, whether it's in a bus or a truck. In the same way, that is a system, brake system. In the brake system, we'll have so many products, as I mentioned. In the product, we have so many parts. So the person who is a beginner generally gets to work in the part level design.
Okay, okay.
So he'll, maybe if we take a simple screw which is connecting, that has so many functions. It has to withstand its operating environment requirement, then only we will not face any failures. So likewise, the junior engineer primarily work on the parts or simple variants. There will be a very minor change that happens in the product, so that it can be used for a new requirement. And then as he grows, as he learns, he work on the next level of critical component. And then it's a system level responsibility.
Okay.
And then it is interaction with the customers, knowing their requirements, understanding their problems, providing solutions, understanding the, maybe right now my role involves the problem solving skills.
Okay.
From the field. If something goes wrong, we have to understand, we have to rectify, and then we have to adapt in our design.
The product life cycle which you spoke, right, from gathering requirements, 2D drawing, 3D prototyping, validation, everything, does it remains the same across industries or it varies with the industry?
Generally, it's a common practice only.
Okay,
Whether
okay.
whether it is an automotive company, whether it's a thermal boiler companies,
Okay.
or whether it's a machine tool companies, most of the time it would be the same. If we see in our core uh, job opportunities, so we have more opportunities in automotive companies.
In automotive.
In
Okay.
automotive companies, because India is a automotive ecosystem.
Right.
We have so many OEMs, we have so many people to drive the car and buses. So the OEMs from different part of the world comes and has their base here. Our economy is growing. So because of the OEM, tier 1 companies are there, tier 2, there are further down the line, there are so many
Okay.
companies are there. So they are all helping us to and then they are providing the opportunities for the people. So to answer your question, so the development life cycle primarily in terms of requirements, and then providing the acceptance
Okay.
to the customer requirements.
Okay.
Because we have to sign off before we go for any development.
Okay. Okay.
Otherwise, during the development stage, if there is any requirement change happens, that has to be considered in the project, overall project milestone, in terms of it may affect the initial project cost and the timeline also. And then we go for the 3D model, and then the 2D drawing. This is from the product point of view.
Okay. Okay.
Then we'll go for the child part design.
Okay.
We have to see whether the parts can be manufactured with the available technologies. You should not design a component which could not be made in any technologies available in the industry.
Okay.
So that also the has to be that is also one of the major capability of a design engineer. We have plastics can be made through injection molding. Castings can be made through pressure die casting or the gravity die casting. So like that, so many sub manufacturing processes are there.
Okay.
So we have to manufacture we have to design for the manufacturing also. So we have to manufacture for the design, design for the assembly, design for the environment, design for the ergonomics.
Nice.
So all these things has to be considered in the design stage itself. Because if something goes wrong during the design, in the entire development life cycle, the same failure or error carry forward.
Right.
So we have to be very careful during the design stage itself.
Right. So design plays a crucial part in whole life cycle, right? So
Because the person who is making, who is working in the production, might not know the whole intricacy behind that feature. Maybe he need to do some machining. Why what is the requirements would be specified in the drawing. So the drawing requirements has to be completely met.
okay.
If that is not meeting, then some kind of failure can happen.
You spoke about lot of teams, like generally with what are the teams you collaborate with? There are design team you mentioned, which you are working with. Maybe you will collaborate with testing team, or what are the other kinds of team you collaborate with and work with?
Okay. So if we mention as teams,
Mm-hmm.
we can segregate in terms of two.
Okay.
One, teams within R&D,
Mm-hmm.
then teams outside R&D in the complete development. If I first speak about teams within R&D, I am working on the design. As I mentioned, there has to be a simulation team who is doing the virtual testing,
Okay. Okay.
and then there has to be a prototyping team who need to develop the initial prototypes, because the parts during the prototyping stage might not be developed similar through the series tooling.
Mm-hmm.
There can be different process. We have 3D printings.
Mm-hmm.
Everything can be most of the designs can be made through 3D printing itself.
Okay.
And then we have materials team.
Mm.
So we have so many materials, like as I mentioned, plastics,
Mm.
aluminum, steel, cast iron. So there are so many materials are there. They may support us to choose which material for our given functional requirements.
Okay.
And then we have the testing team.
Mm-hmm.
They will do the actual testing of the either prototype samples or the series sample. These are the major teams within the R&D.
Mm-hmm.
And then we have a project management team within
Oh.
R&D.
Okay.
They call as engineering project manager. So they are the single point of contact to the other departments.
Okay.
So then if we go outside R&D, we'll have the project manager primarily. He drives the whole project, whether it's a new project or it's a change projects.
Okay.
And then we have the marketing, who is assisting us to collect the requirements from the customer.
Okay. Okay.
And then we have the industrial engineering.
Oh.
So that team works for the development of processes.
Okay.
Uh, design for maybe product design is one part, and then the process design is another part.
Okay.
So they work on the machine selection of machines.
Mm.
Whatever requirements we are providing in the drawing, they choose appropriate machines to achieve that requirements. So they make the assembly lines.
Mm-hmm.
And then we have the quality.
Mm.
So who is ensuring that the requirements are met.
Mm-hmm.
And then we have the supplier development team.
Mm-hmm.
So some of the parts would be made within the company, some of the parts would be made from the tier 2 supplier.
Mm-hmm.
These are the primary teams outside R&D.
Okay.
And then we have the application team also within R&D, who is working with the customer, doing the actual testing in the vehicle.
Actually, coming from IT background, I find this all interesting to hear.
Yes.
Yeah. So, out of all the teams you mentioned, right, which teams is a entry point for mechanical engineering graduates mainly?
I could say
Mm-hmm.
all these teams are equally important.
Okay. Okay.
The entry point could be any of the team.
Okay.
So everything carries its own weight.
Mm-hmm.
Every team has its own processes.
Mm-hmm.
We cannot say this team is better and this team is not good.
Mm-hmm.
So it would not be like that.
Okay.
It primarily depends on the interest of the person.
Okay.
Maybe he can join in a team.
Mm-hmm.
If that team does not suit his interest, maybe he can learn the skill for the other teams, and he can switch his career. That
They can do the
option.
internal switching
Yes.
also. Nice.
Most of the companies are providing these opportunities.
Nice. Okay. We call it as IGP or
IGP.
something, right? Nice. Okay. So I'll be asking you a few list of skill set categories. So you just explain what is that term is all about. So how does it fit into your design engineering role, and what tools or technologies you usually use in the skill set category? Right. So first, CAD modeling tools.
So we have the tools like Creo,
Okay.
SolidWorks,
Okay.
CATIA,
Uh-huh.
NX. All these tools are used for generate a 3D model.
Okay.
But the design engineer has to know the first principle.
Mm.
Nothing but whatever they have studied in their engineering graphics.
Mm-hmm.
They have to know the angle of projections. They have to understand how to generate a 3D model. I would say the learning a tool is not a big thing.
Okay.
So the tool has all the tool has same things within different names.
Okay.
That's the only thing.
Understanding the concept
Yes.
is more
So
important.
I know only one tool
Okay.
because I worked on only one tool.
Got it. Ha ha ha.
So if we know the basics, then we can work on multiple tools.
Multiple tools.
Because now we have so many tutorials available in YouTube itself. So we can just learn tools in a very quick time.
Okay.
Even if they go for their entry level examinations, the examining would be in terms of how they approached the model. So a part can be modeled in a so much way. The approach how they make is what important.
Okay. Got it. Automation or scripting?
That is still evolving
Okay.
in mechanical
Okay.
domain. So primarily we work on manual mode only.
Okay.
So the automation is newly coming thing.
It's evolving.
Yes.
Like, okay. Prototyping and validation.
Yeah, as I mentioned, during the new product design, we'll go for the prototype validation.
Prototype is nothing but building a minimal viable product kind.
Yes.
Okay. Okay.
It only meets the functional requirement. It
Got
will
it.
not meet the lifetime requirement.
Got it.
So we can do the prototypes with a different, as I mentioned, 3D printing is what now we are working on so many things. So initially we could do only plastics through 3D printing. Now technology is evolving. We can do metals also through 3D printing.
Nice. Okay. PLM and PDM tools.
So here also, so there are so many companies offering different PDM. It's nothing but product data management or product lifecycle management.
Okay. Okay.
So it's like PTC is offering Windchill, Siemens is offering Team Center. Likewise, so many other tools also are available. It depends on the company.
Oh, it's mainly for project management kind.
Yes.
Okay. Okay.
So we just need, it's a database. We have to use that database.
Got it.
So we make 3D models with the tool. That 3D models and the drawings has to be stored in a database, and it has to be accessed through all other departments.
Okay. Okay. So mainly for storing your works.
Yes.
Okay.
And then it takes care of all the processes also. How to approve, how to release.
Okay.
The release process is done through the PDM tool.
So maybe it has all the backlogs,
Yes.
which is completed, what's your
Yes.
status, everything. Nice. Simulation tools.
So we have ANSYS. ANSYS is the primary tool which I saw in so many companies they are using.
Okay.
So within simulation we have so many sub checks, like
Okay.
the model has to be prepared. The model which we do during the designing might not, the simulation software could not take it as it's. So they may do certain changes, and then they go for the meshing. Then only they go execute the simulation, and then they will do the post processing and then the results.
Okay.
So ANSYS is the primary tool, and then Siemens is also having a similar simulation tool. In simulation also we have multiple types of simulation. We have 1D simulations available, so that we are doing through MESIM. And then we have 3D simulations through ANSYS. And then we have CFD also, that is also we have ANSYS Fluent.
Okay.
We do that through that software.
GD and T tools.
GD&T is a process.
Okay.
So if we make, for example, if we are making this glass,
Okay.
it has to be flat.
Okay.
So the flatness would be ensured through GD&T. So we have to provide a particular flatness symbol in the drawing, so that during the manufacturing process it would be ensured. So there are certain GD&T symbols are there that we can learn through normal sources.
Okay.
Also it's available in the curriculum also under metrology.
Okay. Okay. Benchmarking and reverse engineering.
So sometimes we might not know the exact product design or exact working of the product, and then we have some competitor who is coming to our market, who is offering a different solution compared to ours. So in that scenario we go for the benchmarking. We just buy that product from the market we'll just understand how they designed and how they what are the principles they used. So this also makes us to understand our we can do a comparison between both designs. If there are certain improvement points, we can take it.
Nice.
Reverse engineering is nothing but from the actual part, the designer will do the modeling and the drawing. He just from the normal development phase, he'll just reverse engineer it.
Okay, okay, got it.
Part, model, drawing.
Ha, ha,
If needed, we can go for the same development cycle and see whether our whether the person's the benchmark one and the person who is making a new one is matching in terms of performance and lifetime.
Nice. So it's more about a competitive analysis. Nice. Cost optimization.
So cost is the primary driver everywhere. So we'll go for the initial development
Okay.
with certain assumptions and certain requirements. So it goes to the market, it is running in the field successfully. Then we have certain opportunities without affecting the product performance. Maybe we can change from one supplier to another supplier who is offering a competitive price. We can go for the slight modifications in the design that reduces the development cost and the part cost. So those kind of things are major, I would say, critical um, points for the design engineer. So it would greatly benefit one's career.
Nice. Oh, there's a separate team to do this cost and pricing itself.
Yes, there is a separate cost analysis team, cost engineering team is
Okay,
also there.
okay. Ha, ha, ha.
But the design engineer has to think in a techno-commercial way. So it's not only technical. We have to think from the commercial aspects also. Whether the design which we are making is best fits for the requirement and the market.
Nice. So whatever.
Ultimately, if we design a product which is too costly, which no one buys, there is no point in it.
Right. So whatever you build, it should come under the budget.
Yes.
Which is mentioned for you. One major doubt which I have personally. So I feel many engineering, mechanical engineering graduates, right? They move into a software or IT roles. Only a few get into this core mechanical engineering roles. So what is the major reason for that? Because of less opportunities or any other reason? Can you talk about it?
So there are so many reasons.
Okay.
So firstly, I would say there are opportunities. There are so many opportunities available
Okay.
for the mechanical engineering. If we see in Chennai, we have so many clusters which are fully focusing on the manufacturing side. Maybe if we take Ambattur, it was a MSME and so many tier 1 companies are situated. Sri Perumbudur is a manufacturing cluster, Varagadam is a manufacturing cluster, and Mahindra World City is a manufacturing cluster. There are so many companies available.
Oh, inside Chennai itself,
Inside
there
Chennai
are
itself.
so many clusters.
There are so many clusters and so many companies.
Okay.
And then if we see in Tamil Nadu, so Coimbatore has a big manufacturing ecosystem. So if we see a water pump, so Coimbatore has a very big presence all over India for the water pump, agricultural water pumps. So people from the north also buys the water pumps from the Coimbatore. So opportunities are there, but of late, if we compare IT, so the initial pay for an IT engineer and manufacturing or core mechanical engineer, it differs in a bigger way.
Got it.
So the IT services companies are providing a comparatively good salary than the manufacturing thing. So if people compares those two and then the career progression that they are seeing in an IT is will not be the same in the core mechanical domain. So they has to have so much of perseverance.
Passion is more
They
important.
they need their passion drives them to go up in the ladder. I see many people who joined in IT, who quit IT and changed their role.
Okay.
They have to upskill in terms of the relevant thing, and then they will start working on the core thing. But they might not get the same salary what they got in the IT in their initial years.
Okay.
So they have to work for 2 or 3 years, and then there will be so many opportunities. This initial 3 years is the major bottleneck.
Hmm.
I know personally many people who joined, who are passionate in manufacturing or the mechanical design side. So they join some coaching classes.
Hmm.
Maybe they teach softwares.
Mm-hmm.
They also provide placements,
Mm-hmm.
but that placements would not be in a very big companies.
Hmm.
Primarily, it would be in the small scale industries.
Mm-hmm.
They learn the course, they learn the software, and then they join in that companies. For the first 2 years, the salary would be very less. It would be less than 20,000.
Hmm.
And then they will learn. Once they move to the different companies, if we see in 6 or 7 years, they would be in a good position.
Okay. Okay.
So taking that risk or taking that journey in this
Hmm. Hmm.
domain needs the backing from the parents and the passion from the individual.
So more of a resilient nature is very much
Yes.
needed. I guess actually I also remember in our college itself during placements there are lots of IT companies which comes first, which offers many bulk placements, right? That is often open for all the departments also.
Yes.
So most of them just go and get an offer, get placed in that IT company, and since they already have an offer, they might not even try other companies also because we have a limitation also only one company per person or likewise. So like these bulk placements also affect in any way.
Yes, because as you mentioned, during our studies,
Mm-hmm.
this kind of restriction they had,
Okay.
one person, one placement.
Okay. Oh, now there is
After
no
after
restriction.
3 4 years,
Okay.
they changed.
Uh-huh.
So a person can have an IT services placement.
Okay.
That person can sit in the
Core.
their core companies
Nice,
also.
nice, nice. Okay, okay.
So at that time they had the options
Okay.
to choose different companies.
Mm-hmm.
Again now, since the situation changes because of the geopolitical reasons, even there are no bulk placements right now.
Oh,
So
okay.
the companies which took more than 100 people are taking less than 20.
Oh. So what's
So
the major reason?
because of this geopolitical
Okay, okay,
tensions
okay.
only, and
Ha ha ha.
then arrival of AI,
Okay.
so that reduces the
Mm-hmm.
intake
Mm-hmm.
for the students. So that is also one of the thing.
Mm-hmm.
And then there are certain roles
Mm-hmm.
in manufacturing. For example, we'll have some maintenance engineer kind of role. So they have to take care of the machine maintenance,
Mm-hmm.
and if they compare their role with an IT engineer role, it would be completely different.
Mm-hmm.
So there will be hard. They had to spend so much time. And also it depends on how the company treats them and how what is their work life balance. If they
Mm-hmm.
compare that to a IT role, so they will think that why should I work here, I
Mm.
could move to IT. So those kind of roles and certain production roles also, it would be monotonous. They have to learn,
Mm.
they have to upskill themselves. Why I need to do this? What is the function behind that thing? So if they has that curiosity, if they learn, they will go in that progression ladder.
Mm-hmm.
Otherwise again they will, if they compare themselves with an IT,
IT, yeah.
again they think I can go to IT.
Mm-hmm.
So those kind of things also are there.
Right, right, right. As you said,
It completely depends on the individual preference.
right. Yeah. The individual's interest, passion. So a strong passion is required for this, I guess, to continue the entire journey, to continuously learn, upgrade, to be in the core itself. A strong passion is required.
Yes.
So just curious, do core engineering like mechanical engineering jobs also have on-site opportunities?
Yes.
Okay.
So maybe that also depends on the company.
Okay.
So we have so many MNCs. The
Mm-hmm.
company which I work also is an MNC. So it will be under top five global MNC.
Mm-hmm.
But now all the companies are facing in automotive domain. If I say, all the companies are facing difficulties,
Mm.
like the Russia-Ukraine war, the tariffs. So all
Mm.
these things, all the profitability of all these companies are very much difficult.
Okay.
Right now, the opportunities are less. Generally, there are opportunities.
Good opportunities. Nice. Okay. I guess you must have interviewed many candidates, right? So what are the must-have technical skills you expect from a candidate during your selection process? If you had to choose the top three must-have technical skills.
Okay. So it depends on the entry point.
Okay.
If they are a fresher, we'll primarily look into their curriculum
Okay.
and their interest and their college projects. If you are looking for people at early career for 2 years or 3 years, so what kind of companies they were working, what is their role. After 5 years, that also depends on the certain skills that we look for.
Okay.
So if I need to say, I have not done any personal interview from the company,
Okay.
but I did many interviews in the colleges. So
Okay.
I went for mock interviews
Mm.
to College of Engineering India for the
Okay.
mechanical engineering students for the past 7 years.
Oh, nice.
So from the alumni side,
Mm-hmm.
so we'll during the interview process we'll understand what is their area of interest,
Mm-hmm.
and then in their area of interest, do they have the basic understanding.
Mm-hmm.
So and then their project execution
Mm.
and their involvement in the project.
Mm. Okay. Okay.
So if the fresher work already had some hands-on experience to work in a 3D model,
Mm.
that's always an advantage to take him in the design role.
Mm-hmm.
So and then he has more curiosity in the automotive domain.
Mm-hmm.
He learned so many things. That is also an advantage for him.
Mm.
So those kind of things I look for.
Apart from these technical skills, what are the other traits or qualities or soft skills which you train them or look for them before telling that this guy or girl is a right fit?
So in the manufacturing domain, generally, so they have to work in a team.
Okay.
The individual contribution role would be very less.
Okay.
So
Okay.
they have to adapt to the team,
Mm-hmm.
and they have to effectively communicate,
Mm-hmm.
and they have to be accountable on their roles.
Okay.
So these are the major traits we have to look
Nice.
for.
Accountability and team collaboration.
Yes.
Nice. So your mechanical design engineering role is more of a desk role, or does it involve some kind of field work also?
The design we make
Mm-hmm.
is through system only.
Okay.
It's through computer only,
Okay.
and the verification, release, everything happens to the system only.
Okay.
And then once we if the design engineer has to have more understanding or more hands-on experience, he has to go through the entire development process.
Mm.
With just an initial release, if we just okay, I completed my task, then the actual things will take place. Instead of that, we had to go for the all the steps. So when they go for the prototyping, whether the design we made, if the prototype supplier is asking some changes so that it is easy for them to manufacture,
Mm.
if the changes are okay for us, if they are that does not make big difference in the product function, then we can allow that. So it may reduce the cost as well as time.
Mm-hmm.
And then once the actual prototypes comes, that goes for the testing,
Mm.
and that prototypes has to be assembled and that goes for the testing. During that time also, if the design engineer is present, he will just practically see what he designed, what he saw in his computer. He can see he can feel that with his hands also.
Mm-hmm.
If he do the assembly, then he will understand where he can further improve.
Mm-hmm.
And then the testing will takes place. It will be done by the assigned test engineer. If the design engineer is present, he will also understand how it performs.
Okay.
So this is one cycle. And then if we goes to the series development cycle, there also the supplier may ask certain queries. If you change this, If you change in the drawing, there will be tolerances. If you just change this tolerance, it may drastically reduce the tooling complexity. If the design engineer understands that, and if he checks that does not have big impact to the function, then if we allow that change, that will this will that will benefit the company a lot. Also the series part assembly, series part testing, and then we will provide that to the customer also. The product which we design will be fitted in a vehicle. So if we are interested, and if we go to that up to that stage, we'll see how that is functioning in the vehicle. The product which I designed is going in the road.
Nice. Okay.
So the EV vehicles that are going, the compressor, I worked on that compressor. So when I see that, it provides a big
Impact, that
impact.
happy moments of
Yes.
the role. So as we spoke, right, many people might have accidentally landed in a IT role, or many aspiring mechanical engineers like who wanted to get into the core role might have started their career in a very low salary package in any production unit. So for these people, so what would be your advice on where they have to start, how they have to prepare themselves while being in a job? So your tips, please.
Yeah. So generally, if the person joins in a company or joins in a role, maybe within first 6 months itself, he will understand whether the role fits for him, whether he likes that or not.
Okay.
If the in the mechanical domain, there are so many departments: mechanical engineering, manufacturing, automobile, industrial, material science, production. So all these uh, engineering curriculum comes under mechanical domain. If they are, maybe as you mentioned, they may join in a production unit, or they may join in an IT company. So if we take in the production unit, so primarily they have to first understand what they are working. So if design is their aspiring role, so then they has to understand, if they are making a product in the manufacturing cell, they need to understand this part this part is part of which product.
Okay.
What is the function of that product? If I do some mistake in the part which I am producing, what kind of impact it creates in the whole life cycle? So if they are that much curious, they can very well aspire to be a design engineer. So to take that steps, maybe there are multiple options. The company they are working,
Okay.
if that has a design department within their premises or within that company, so they can approach if there are any opportunities. So it would not be so easy. They have to convince the design team that I am a good design engineer, I would be a good design engineer. So for that, the expectation would be, as I mentioned, first principles. They need to understand the basics of the technical basics, and then if they have to work on the modeling skills. Any software, the softwares which we already discussed. So if they worked on that, and then if they has the basic technical understandings, they can approach. Otherwise, the other opportunity would be they can go out, or they can parallelly learn design tools through consultings,
Okay.
and then they can approach with that experience with the other outside companies. I have seen people who did this route, first 2 years in a production cell, and then learn a software, learn the basics, and then switch to a entry level job. The salary will be less. So from there their career progression starts. After that, they have to upskill themselves. So after 2 or 3 years, they will learn, and then they have to approach other companies.
Okay.
So within 6-7 years, their career progression will be set. After that, they are on their own. They could bring
Nice.
up their career. Similarly, if we take an IT employee, they are also a similar approach. But here, the convincing the design team would be still further difficult. They have to show their passion.
Right.
during the interview. So to go for the interview, they have to build their resume, build their profile, so they can do projects outside. They can work in an IT. They can contribute some outside projects, build their resume, learn the software skills, and then they can go on. The
Okay.
software should be used during their initial career only. After 5 6 years, the usage of software would be very limited,
Okay.
and the principle behind that design would be very important.
Okay. The basic foundation, the core
Yes.
concepts, the understanding of core concepts. Nice. So that was a good actionable point which you mentioned. Okay. So the one last final question. So we have spoken about many things. So how does a day of your mechanical design engineer looks like? You'll be in meetings, or how does your day looks? What all activities you do? Just a small recap.
Okay.
Yeah.
So if we see primarily,
Mm-hmm.
so as all employees do, we'll have emails.
Okay.
So we have to check all the emails that has come, and we have to respond to that, and we have to take any activity that needs to be done from that. We have to list down that, and then we'll have our activity tracker that we have to do, and then we have to go for the, if we are in a design release phase, we have to work on the um, design, the specification finalization, the drawing finalization, and then the simulation. If the simulation team does completes the simulation, we have to see how that impacts to the design. If we need to do any modification, we have to do that. And then if there are any problems that was identified during the development stage within company or within the customer end, we have to address those issues. And then there will be always meetings. So there will be multiple projects, there will be multiple tasks assigned, so we have to attend those meetings and fulfill our accountabilities. It goes on like that.
Okay, yeah. So thank you so much for sharing so many insights. You explained it in very simpler terms. Everyone can understand. So thank you so much for coming here and joining us a guest in this podcast.
Thank
Yeah.
you.
Subscribe to our Beyond JD YouTube channel so that you don't miss when your favorite role comes. Thank you.